Today we're going to look at bearings in respect to how we might use right-angled trigonometry. So let's talk about what bearings are. Bearings are a measurement that are used to navigate ships or aeroplanes because there are no roads or road signs. The general idea about bearings, there are three main rules that need to be followed. The first rule is that the bearing is always taken from the north line. So you always start at the north line. The second rule of bearings is that it always travels clockwise. So you begin at north and you move around clockwise. And the third rule of bearings is they're always communicated in 3 digits. So for example, if I was going to give you a true bearing, and these are true bearings, there are other bearings, but we're just working with true bearings. If I gave you a true bearing, and true meaning it's coming from north, of 79 degrees, it would be written as 079. And sometimes they actually put a T next to it to say it's true bearing. Sometimes the T is at the front, but the T represents this set of rules. All right, the other thing you need to know about bearings is direction, because often questions involve compass directions. So I'm going to draw the basic compass direction. Now, I'm from England, and in England we used to have a cereal called shredded wheat, and the general rule was never eat shredded wheat. I'm not sure Australia has shredded wheat, but you can come up with your own acronym to remember that. Now, you should always know that there is 90 degrees between each of the 4 compass points. Between north and east, it's 90 degrees. You also should know that there's 180 degrees between north and south, and similarly, between east and west, 180 degrees. You should also know that from north all the way back round to north is 360 degrees, because there are 360 degrees in a full circle. Sometimes we refer to northeast, sometimes we refer to southeast, and similarly southwest and northwest. And that just generally talks about the direction that you are headed or facing. Now what you need to do is understand the wording of bearings following those 3 rules. So I've put an example up here. Find the bearing of B from A and then A from B. And here's the diagram that we have here. So we've got 2 towns, A and B, and we have some information in the east direction. So let's have a look at the first question. It's asking us to find the bearing. The bearing is just how much of a turn from A to B, basically. So if we're going to follow those 3 rules, from A, we always start from the north line. So I always draw a north line on the diagram. So we're going from A to B. So let's see what the turn is from A so that we are facing B. So having a look at this, we know that between north and east is 90 degrees. So the bearing between A and B is 55 degrees, but we need to write that properly because it's got to be 3 digits. So the bearing is 90 minus 50. Sorry, what am I on about? 90 minus 35, which is 55. So we write that as 055t because it's the true bearing. Now let's look at the second example. It says, find the bearing of A from B. So we're going from B. Here's town B. We're going to start facing north. And we want to turn around to face town A. So let's just draw this on the diagram now. I'm just going to draw a dotted line down here because that will be the southerly direction. That's south. Okay, that's facing south. And if I'm starting at B, facing north, I need to turn all the way round to there so that I am facing town A. The difference between the north and the south line is our 180 degree. I need this angle from the south line to here. Now what we already know from part 1 is that this angle here is 55. We also know that these 2 lines are parallel because just of the nature of the north and the south line. And we can see in our diagram. Parallel lines produces our alternate angles. So we also know that that is 55 degrees. So the bearing of A from B is going to be 180 plus the 55. And remember, we must write that in 3 figures, so it's 235t, following those rules. Now let's suppose I introduced another town. Let's go town C up here. And let's suppose we did have some information about town C. Let's suppose we were given this angle here. This is west. And let's suppose we were given, this is 70 degrees. So again, what we're going to do is we're going to find the bearing of C from A, and we'll do the other way around, A from C. So let's start with the first one. Let's call this 1 and this 2. So C from A. So we're starting from A and we're headed towards C. So obviously I've got all this information here which may be off-putting. So I guess in a way you just have to kind of ignore this. But what I can do is just rub out some of this information, because it can look a bit overwhelming. So let's just ignore some of this. Now we're going from A and we're facing C. So remember bearings, 3 rules. You must start at north and you must turn all the way around clockwise to face the town C. What we do know is that the difference between north and west is 270 degrees. And then the further degree that we've been given from west to C is 70. So the bearing from C from A is going to be 270 plus the 70, which is the 340 degrees. So 340T is what we write as our answer. Now let's do the other way. We're going from C this time. So from C, draw in your north line. So the 3 rules, north, following clockwise. Clockwise so that we are facing town A. Now what we can see here is that the difference between north and west here is 90 degrees. So if that's 70, we do know that that is 20 degrees to make it up to 90. Now let's follow this supplementary angle rule, which says that when you've got 2 parallel lines, that the 2 angles between them add or total to a sum of 180. So A plus B equals 180 degrees. So we have this scenario in this case because we know that the 2 north lines are parallel, and we know that this is 20, so this one has to be 160 degrees in order for those supplement angles to add up to 180. So to calculate that, we did 180 minus the 20, which gives us 160T. Okay, and that is everything you need to know about the basic wording of bearings.